Hey guys, today I'm going to be doing example number 4 out of the PDF. What we have going on here is a string of protons moving through a magnetic field. They're kind of getting bent downwards just like this. We have a magnetic field rating of 0.0476 Teslas in the K direction. We have kinetic energy of 4.74 million volts here. And then we also note that we're moving from 0 meters to 1 meters is the section of this that we're looking at. So what we're going to do is start with Newton's second law. The force is equal to mass times acceleration. Specifically mass with a proton here. And we're going to be also looking at the formula for an electric field and magnetic field. So the charge times the electric field plus the velocity across the magnetic field is equal to the summation of forces here. Yeah, that should just be summation of forces here. So what we can do is take this equation right here, plug it in over here. So this becomes the charge of the proton times the electric field plus velocity across B is equal to the mass of the proton times the acceleration of R. So let's take a look at this picture here a little deeper. We have this coming down this way. This will be our x-axis. This will be our y-axis. So we're going to pick a point right about here and drag this down. Alright, so we'll label this angle alpha, and because this is a right angle right here, this will be 90 minus alpha. And then, through magical geometry, we'll also label this angle on this side as alpha, and over here is 90 minus alpha. We'll label this segment A, this segment B, and this segment C. So this will be useful in really finding exactly what the velocity is here. So we can take a look at the specific point and then kind of find it as a whole. So let's continue on with this equation over here. Because we are working with radial measurements, acceleration is going to be equal to velocity squared over r. So the mass of the proton times velocity squared over r is equal to the charge of the proton. And then what we're going to do is, because the electric field isn't really present here, we're just going to go ahead and take that out. So this becomes V dot B, just like that. So then we're going to solve this equation for R. We'll bring R over on this side, so R is equal to MP V squared over Q V QP V B. We can cancel out these V's here, so R is equal to mass of the proton V over QP B squared. So if we plug in some values for this, the mass of the proton being 1.67 times 10 to the minus 27, I believe, and the proton charge being 1.6 times 10 to the minus 19. We can also plug in the Tesla rating and the voltage rating here, and this becomes R is equal to 6.6084 meters. Now what we're going to want to do, that we have R, R is also C here. Actually, let's forget C. I'll just label this as R. So what we'll want to do is just use simple Pythagorean theorem to find a and b at this point. So we'll just do b is equal to root r squared minus a squared. And once we solve for b here, we get that b is equal to 6.5323. So we get some small, they're not very different from each other, so we know that the angle here has to be pretty small. And then we'll just use some trigonometry, that the inverse tangent of a over b is equal to this angle right here, alpha. Oh, and we know that a is equal to 1, because this is x is equal to 0, and that's 1 right here. So it's minus tangent of, or I guess you could say arctan 1 over 6.5323 is equal to alpha. If you plug that into your calculator, you get alpha is equal to 8.704 degrees. Now what we want to do is solve for the velocity in y. So we'll just use this basic formula. Velocity of y is equal to minus velocity sine of alpha. And once you plug in values for that, this becomes minus 4.56 times 10 to the 6th. And then what we'll do is multiply it by the weight of a proton. So we can find the moment of inertia here in the end. So Py is equal to the mass of the proton times the velocity in y, which mass of the proton is 1.6 times 10 to the minus 19. Oh no, sorry. 1.67 times 10 to the minus 27 times 4.56 times 10 to the 6th is equal to minus 7.616 times 10 to the minus 21 kilograms per meters second.